Hello, welcome back. In our previous video, we looked into breakpoints and the continue feature. Using that, we could actually introspect our code when it was running to great extent. But there were other features, that is mainly step into, step out, and step over. So those three features we wanted to explore. For that, what I have done is in my debugger, I would like to remove all the other breakpoints except the first breakpoint. So I can actually delete, you can get rid of these breakpoints, right? So only one breakpoint is there right now. If you go to main.c, only this is the breakpoint that we have. We don't have any breakpoints here, neither we have any breakpoints inside main.c. That is the setup with which we will be beginning with. At the same time, I'm running that in the watch mode, running the program in the watch mode, and obviously it is failing. There seems to be some bug, right? So, and as we have learned in the TDD, whenever that bug is encountered, a test will be failing, and that is going to guide us, right? So now we know that the failure is happening here. So in the test.c, if you go and see, you are 100% sure that these test cases are passing, but only this is the test case that is failing. So now obviously, logically, what we will do is we want to actually come here directly. We don't want to actually keep debugging all these invocations. That's why we have removed all the breakpoints in the prime.c, right? I mean the prime.c file inside isPrime function, so that we don't want to go there again and again for these four cases. We directly want to jump to the test case where we are passing number 4. Right? That is why we intuitively are placing the breakpoint. This is like we dynamically decide during a trip, hey, this place is looking interesting, let's stop here, right? Same thing we are doing here as well. So we see that this is the area of problem, so we have added a breakpoint. Now I can go to the debugger and I can bring up the debugger and debug this test case, why it is failing for this test case. Okay, now I can run continue, right? Because I have a breakpoint in that test, so I'm confident that it's going to stop here. Now, how do I get inside this isPrime function? One way to do that, our good old way, I can put a breakpoint and say continue. That is another way. But there is another way, a better way. So I am here and I have not placed any breakpoints inside this function, but yet I want to enter into that. But that, as you rightly guessed, that is the step into for our rescue. Look at that. The moment I do that, I get inside this, right? Now I know the number is 4 and I can actually debug. Now I can actually debug line by line using this step over. So even if there is a function invocation, step over is not going to care, right? So it simply is going to run the line as a whole, okay? So here it might not make much difference between step into and step over, because there are no other function calls. So behavior of step over and step into will be the same. For now, let's use step into. So number is equal to 2. This also should hold. This condition will be false. So you comment this for loop. This is the place, right? We need to deeply introspect. Okay. So let's go to the debug pane. So now this I is equal to 2 and number is 4. Obviously here now we have not entered into the loop, but our proposition is that we should enter into this loop for number 4, isn't it? Because there is a divisor for 4. We all know that 4 is having a divisor other than itself and 1, that is 2. 2 is a divisor. So because of that, we anticipate it to come here and we anticipate that it should not come here. So what do? We intelligently place 2 breakpoints to see whether it comes or not there, right? If it does not come, there seems to be some problem with this condition then. That is the indication. So to do that, you can either press continue, you can press step over or step into. Anything will work because you have placed breakpoints. Control cannot go beyond that. For now, for the sake of simplicity, let's keep using step into. Let's see what it does. So in this line, there is an invocation for square root sqrt. Let's see whether it gets inside that. No, it doesn't get inside. The reason is that it is a library function, okay? And the debugger is not aware where is the source code of sqrt. So it will not take us to that. That source code is missing, okay? So we don't have that source code. So it doesn't take us there. But since there is a bug, we end up coming here. Why it is happening? Because we have forgot to add that equal sign. Because of that it is failing and it's coming here and ending up returning true, isn't it? Let's come out. Now of course if we continue the execution further, we can keep on pressing step into, no problem. But do you think this execution will continue? No, it is not going to continue. It is going to abort, right? Because the assertion is failing and under the hood it is just going to exit the program. That is what is happening. Now what I can do is I can go back to that prime.c and I can actually add that and save it, and I can actually restart debugging again, right? So let's do that. Let's use that restart button. So as usual, the same thing will happen, and now inside our test files, so I can test file, we know that we have a breakpoint, so we can confidently say run, but of course we had few breakpoints already inside our isPrime. Because of that, for other test cases also we might hit those breakpoints, right? For example, for number 3 it is saying true, so you can remove them, but that's okay. Now you know, right? So you are inside that because of these breakpoints. So I come out of that, right? Now let us say that I want to skip these lines, and for that, this step over, the meaning of step over is something like this. Hey, even if there is an invocation of these functions, don't get inside that function. Instead, you simply execute that line and take me to the next line, right? Following it. Provided any invocations that are happening here do not have any breakpoints. If they have breakpoints, mandatory stop it is. Okay. So for example, I can try step over here. I end up going there, isn't it? Because there was a breakpoint. So if the breakpoints were not there, what is going to happen? Now you can actually run the line as a whole. Look at that. It is not taking you inside that isPrime. See, you can skip. Let's say we are interested only in 997. This test case we want to debug. So I can do this step over, right? It's not going to take me inside this. So simply it's going to execute the line as a whole and take me to the next. Now if I want to get inside, I can go do this. And I can actually potentially debug. I can say step over, line by line, I can debug. Here again, there is no difference between step in and step over, because these lines do not have any calls, invocations to functions which we have written. So meaning of these two things will be the same. So even if I press this, so of course you end up iterating like that, right? So I is equal to 3, I is equal to 4, and so on and so forth. Of course, you can sit and debug this. You can trace what is happening, which number you get, whether there is a divisor or not. All those things step by step you can debug. You can loop through and see what is happening. But let's say that you don't care. You are bored. It's as good as in real world. You get inside a museum and you see some artifacts and then you get bored. Oh my God, I want to get out. Right? You can do that, right? You should be allowed to do that. Here also, if you want to ignore the other lines, but still the debugger is going to run those lines, right, for you, but it is going to take out of that invocation, right, prematurely. That is where the step out, right, optional gateway to come out, right, escape route. So this is the escape route. I want to come out. I'm not interested to debug that 997. Maybe I want to debug some other test case, right? So I can jump the lines like this using step over. But if I am interested, I can always step inside and investigate what is happening. If I don't care any other lines in that function, I can always come out of that using step out. Okay, so this is how we use these other controls as well, as and when needed. And at the same time, we noted that where we place breakpoints also depends on our context. In this case, we knew that it is failing for a particular test case. Because of that, we ended up placing a breakpoint for that particular test case, and we removed all the other breakpoints, and we went there, and from there we carefully stepped inside that function, and we could actually introspect what is going on, what is going wrong, and fix it and continue again. So it is as simple as that. So debugger is our friend, and debugging skill is very important as a developer. So I invite you to go ahead and practice this. But to do that, we should set up the debugger first, isn't it? That is something we'll do in our next video. Stay tuned. Thank you.